Hi everyone, this is Mrs. J, and today we're going to learn about quadratic inequalities. But first, please pause the video and give this warm-up a try. Alright, go ahead and check your answers here. I used negative b over 2a to find the x value of my vertices, and then substituted it back in to find the y values. So today, instead of solving quadratic equations, we are going to be solving quadratic inequalities. We're going to learn two different methods of doing this. We're going to do it graphically and then algebraically. So when we're solving these types of inequalities graphically, we are going to want to set one side of our inequality to 0 first. Then we're going to graph the quadratic equation. Then we need to look at it and interpret which part of the graph is our answer. So remember, with inequalities, it's no longer just single values as our answer. It's actually intervals or areas that are our answer. So if we are looking for where our equation is greater than, if you see this greater than symbol, we want to shade whatever's above the x-axis, and those x values are going to be our answer. And if we're looking for where the quadratic is less than 0, we want to shade below the x-axis, and those intervals will be our answer. And just remember, our answer is the x values of those intervals. And then we just need to make sure we use the proper notation according to the directions. All right, let's give this first one a try. You can see that one side of our equation is already set to 0, so we're ready to graph. And this is actually one of the graphs from our warm-up. So for this one, if you look back at our warm-up, we had already found the vertex, which for this one was -1, -4. So we'll graph that. And then if you look at the vertical growth pattern, remember, it's always our a value times 1, 3, 5. So since our a value is 1, it's going to follow the 1, 3, 5, 7 vertical growth pattern. So up 1, up 3, up 5. We can reflect it over our axis of symmetry. All right, so here's what our parabola looks like. And now we actually have to interpret what our what intervals will be our answers, because again, we're not just looking for where it's equal to 0. In this case, we want to see where our quadratic equation is greater than or equal to 0. So since it's greater than, that means above the x-axis. So I see that that's happening here and here. So these two intervals are going to be our solutions. And in this case, it is greater than or equal to, so we will include these values of -3. This value is -3 and this value is 1. We will include those as part of our answers. So in this case, we want our answer in interval notation. So I can see the first interval of my answer. This part is everything to the left and including -3. So in interval notation, that would be -∞ to -3. I'm going to do a bracket because -3 is included. And then the second piece is going to be everything 1 and to the right. So we have 1, which is included, to +∞. So there you go. So again, with quadratic inequalities, it's no longer just values that are our answers. It's actually intervals that will be our answers. All right, let's try another one together. So we're going to solve this one graphically as well. One side is already set to 0. So if I go to graph this, this was actually one from the warm-up as well. So we already found the vertex for this equation, which was 2, -9. And then if we look at our vertical growth pattern of a times 1, 3, 5, we just have the 1, 3, 5, 7, so on and so forth. So I can go up 1, up 3, up 5. And there we go. Okay, so now we have to decide where our answer is. So in this case, we want to know where the quadratic is less than 0, meaning below the x-axis. So that actually falls in a single interval. So we can see that that's happening from -1 to +5. So again, our answer should be the x values where our graph is below the x-axis. In this case, we want inequality notation. So we have -1 is less than x is less than 5. In this case, it's only less than, not less than or equal to, so let's make sure these are non-inclusive. And there you go. So sometimes you can see that our answer will be a single interval, like this example, or like the last example, it may be two separate intervals. All right, at this point, please pause the video and see if you can give this one a try on your own. All right, go ahead and check your work here. For your graph, the vertex should be at -4, 1, and it is a downward facing graph. The x-intercept should be at -5 and -3. And here we're looking for where our quadratic is greater than 0, so where it's above the x-axis, so between but not including -5 and -3. So an interval notation that would look like this. So now we're going to move on to solving quadratic inequalities algebraically, which would probably be the method that I would choose if I have the option. So for this, we are going to first treat the inequality like an equation, and then we're going to solve using any method that we see fit. So then once we have solved like an equation, we're going to use those x-intercepts to help us to find the intervals, and we're going to do what's called a sign analysis. A sign analysis allows us to see where our equation is positive and where it's negative, which also means where it's above the x-axis or below the x-axis. And then if we have an equation that is asking us for where it's greater than 0, we're going to select the positive interval or intervals. And if they're asking us for when our equation is less than 0, we will select the negative intervals. So learning this method or this process of performing a sign analysis is going to be super, super important. It's a very fundamental skill that you will use over and over again as you progress through harder levels of math. All right, so let's give this one a try together. So here we do have this inequality, but first I'm going to solve it like an equation. I want to know where this equation is actually equal to 0, and then after that I'm going to figure out where it's less than 0. So you can use whatever method you see fit, but as we've talked about, if something is factorable, that's the method I'm going to pick. And this one, what multiplies to make -4 and adds to make -3, -4 and +1. So x minus 4 and x plus 1 are the factors. And then we can do zero product property to finish solving. So we have x equals 4 and x equals -1. So now that we know where our equation is equal to 0, we need to figure out where it is less than 0. So there are different ways to do this, and I'm going to show you a few different ways. One way we can do this is we can test different numbers within our intervals to see where our graph is positive and negative. So I do like to set up a little number line. It's not at all drawn to scale. I just need to make sure I have my two zeros and that the smaller one is to the left of the larger one. These two zeros have created 3 different intervals. So I need to figure out in these 3 intervals if my graph is positive or negative. So one way you can do this is you can pick any number in this interval. So you can pick literally any number to the left of -1 and you can plug it into your equation. So let's test x equals -2. So if I plug in x equals -2 to our equation, we have -2 squared minus 3 times -2 minus 4. So it gives us +4 plus 6 minus 4, which is 6. So that's a positive number, so I'm going to put a little plus sign, and I like to put it above my, my number line just because it's above 0. Now I need to figure out what's going on in this interval. So I'm going to pick any number between -1 and 4. If you can pick x equals 0, that's usually the easiest one to test. So if it falls in that interval, I would recommend picking it. So we have 0 squared minus 3 times 0 minus 4, which equals -4. So in this interval, you can see that our graph is negative. So I'm going to put a little minus sign, and I like to put it underneath my number line. And last, I need to pick any value in this interval, so any number greater than 4. let's test x equals 5. So we have 5 squared minus 3 times 5 minus 4. So 25 minus 15 minus 4, which is 6. So we know that in this interval, our equation is going to be positive. So here is a sign analysis. I know the sign of my equation over the different intervals, and I know that at -1 and 4, my equation is equal to 0. So now we just need to figure out, well, which part would be our answer. So we're looking for where our equation is less than 0. Less than 0 means negative, so that means our answer is going to be here. It is not inclusive, so that means our answer is between, but not including, -1 and +4. So that would be our solution. Now I want to show you just a different way you can perform a sign analysis. I think it's a little bit more efficient, and it's definitely a method that you will see as you progress through math. So I'd like for you to be familiar with it now. I'm going to set up my same little number line using the x-intercepts to set my intervals. Then on the left side over here, I'm going to list any factors of my original equation, even ones that are constant. So here I only have 2 factors. I have the factors x minus 4, and I have the factor x plus 1. So I'm going to look at these 3 intervals, and I'm going to ask myself, would this factor be positive or negative in these 3 intervals? So you're essentially checking values. So any number to the left of 1, if I take that, let's say -2, and I subtract 4, I know it's going to be negative. So I'm going to put a little negative here. And I know anything smaller than 4, so anything between -1 and 4, it's still going to be negative. So I'm going to put a negative here. Now I know that any number larger than 4, like 5, if I do 5 minus 4, it's positive. So anything after 4, this particular factor becomes positive. And it will always change at the 0. So if the factor is x minus 4, it's going to cross over at +4. So kind of same process for this factor of x plus 1. I know that anything to the left of -1, it will be negative, but any number larger than that, like 0, 1, 2, 3, 4, 5, 6, those will all be positive. So this factor is positive to the right of -1. And then I just need to look at the product of those signs. So in this interval, everything less than -1, I have a negative factor times a negative factor. And when you multiply 2 negatives, we know that the result is a positive. Now in this next interval, between -1 and 4, I have a negative factor times a positive factor, and that product will always result in a negative. In this last interval, for all numbers greater than 4, I have a positive factor times a positive factor, which will always yield a positive result. So you can see that I end up with the same exact sign analysis. I know that my graph goes from positive to negative to positive, and then I can look and say, okay, I want where my graph is negative or less than 0, so I get the same answer. So to perform a sign analysis, again, you can set up your number line and physically plug in numbers in each interval to test, or you can do a sign analysis of the individual factors. This really works when our equation is factorable, so you may have to resort to plugging in numbers, or you might be able to use this method. Okay, let's try another one together. So first thing to notice right off the bat, we do need to set our inequality to 0, so I'm going to subtract 32 from both sides. So we get x squared plus 4x minus 32 is greater than 0. Now from here, remember we want to solve this as if it's an equation. So I'm going to change that inequality symbol to an equal sign. You can solve this however you like. Remember, if something is factorable, that is always the method that I will pick if we have the choice. So we have x plus 8 times x minus 4 equals 0. And then a little zero product property allows us to finish solving. So x equals -8 and x equals 4 are the 2 times where our equation is equal to 0. But we want to know where our equation is greater than 0 or positive. So now we have to do our sign analysis. So I'm going to do that over here on the right. I'm going to use the factors and do a sign analysis of the individual factors. So we have two factors. We have x plus 8 and x minus 4. So for x plus 8, I know anything less than negative 8, like negative 9, will end up being negative. But anything bigger than negative 8, like negative 7, if I do negative 7 plus 8, everything above is positive. So it's negative and then positive, positive. And then for the factor x minus 4, anything less than 4 will be negative. Like something here, 0 minus 4, negative 9 minus 4, those will both be negative. And then anything to the right of 4 will be positive. And then remember, I look at the product of the signs. So a negative times a negative will give us a positive result. Here, a positive factor times a negative factor will give us a negative result. And last, a positive factor times a positive factor will always give us a positive result. So for here, I do want to point out that although it's the same pattern we saw in the last example, not all sign analyses will look like this. In fact, they don't always alternate. Just because this first interval is positive does not guarantee that the next one is negative. So it is important that you go through the whole process thoroughly to do your sign analysis. Or again, we could test numbers. We could plug in negative 9 into our equation. We could plug in 0. We could plug in 7, for example. So you could also do that method to get the same signs. So now we have to figure out, well, what's our answer? So here we want to know when our equation is greater than 0, meaning positive, and I can see that that's happening in two separate intervals. Here it is still not inclusive, but we do have two intervals of our answer. So this interval we can describe by saying negative infinity to negative 8, and then the second interval will be 4 to infinity. And that is our solution. All right, so now it's your turn to pause the video and give this one a try. All right, go ahead and check your work here. First, make sure you set one side of your inequality to 0, and then solve as if it were an equation. So this one I factored, so 2x minus 1 times x plus 2 to help me find the zeros at 1/2 and negative 2. So again, this is where our equation is equal to 0, so our sign analysis will allow us to see where our equation is less than or equal to 0, which ends up being between negative 2 and 1/2. All right, I want to do one last example together with you guys. So here we have this quadratic equation, negative 2x squared minus 12x minus 16 is less than 0. So there's a few different ways we can approach this. First, we could leave the equation as is, and we can solve it. So here I will always start by factoring if I can, and I do see that there's a GCF of negative 2, so I can factor that out. And then I have a quadratic that is further factorable. So I have x plus 4 times x plus 2. And notice that I'm not losing that factor of negative 2 here. Although we don't use it for zero product property, I'm still going to keep it in my steps. So x equals negative 4 and x equals negative 2. So again, these are the values where my equation is equal to 0, but we need to figure out where this equation is less than 0. So here's where we move on to our sign analysis, and this is where typically things can go wrong for people because a lot of people forget to include the factor of negative 2 in their sign analysis. So I know that it doesn't have an x in it, but this factor does actually affect the overall behavior of our equation. So notice that every single part of our equation, every factor needs to be included. Now, if you're doing a sign analysis here, negative 2 is always negative. There's no variable, so it's not changing. It is a constant, meaning not changing. So we do need to include that negative in all three intervals, which will affect our answer. And then for x plus 4, it's negative to the left of negative 4, and then positive and positive. And then for the last factor, it's negative, negative, positive. Now, if you look at the product of your results, a negative times negative times negative results in a negative. In that middle interval, we have the two negatives, which will cancel out, so our result is positive. And in the last interval, that single negative makes it negative. And now to determine our answer, we're just looking for where our equation is less than 0, again meaning negative, and that's happening in these two intervals. So from negative infinity to negative 4 and negative 2 to infinity. So when you have a factor that is a constant, especially a negative constant or specifically a negative constant, you need to make sure that you're not losing it when it comes to your sign analysis. Now, if you just do the method where you're testing points, if you're testing values and plugging them into your original equation, you shouldn't have that issue of forgetting about the negative. All right, that is all for today's video. Thank you so much for watching.